So we know that the derivative of the natural log of x is just 1 over x. And we also know that the derivative of the natural log of some function of x by the chain rule is equal to the derivative of that function divided by that original function. So for example, let's say that we were asked to find the derivative, d over dx, of log to the base e of 5x. Well, if we compare that to this equation here, okay, our f of x in this case is at 5x, and our derivative of f of x would just be 5. So our answer to this problem would be our derivative, which is our 5, divided by that original function, our 5x. So our answer being just 1 over x. If we do another one, we are asked to find the derivative of the natural log of 3x squared take x plus 4. So my function in this case, my f of x, is my 3x squared take x plus 4, and my derivative of that function is just 6x minus 1. So the answer to this question would be that derivative, 6x minus 1, divided by that original function. Thirdly, let's say that we were asked to find what the derivative of the natural log of the square root of x was. Well, in this particular case, my f of x is equal to my square root of x, or just x to the power of a half. So my derivative of f of x would be a half times x to the power of negative a half, which is just 1 over 2 root x. And so the answer to this question would be my derivative, so 1 over 2 root x, all divided by that original function, the square root of x. So this would be 1 over 2 root x times the square root of x, so just 1 over 2x would be the answer. If we do another question here, question 4, so we're asked to find what the derivative of the natural log of x squared times the sine of x is equal to. So again, in this case, my function, it's getting a little bit harder now, my function is equal to x squared times the sine of x. If I want to differentiate this, I'm going to have to use the product rule. Okay, so this is where we start to tie the product rule and the chain rule and the quotient rule into these sorts of questions. So the derivative here would be my derivative of the first part, keep the second part the same, add on, keep the first part the same, multiply by the derivative of the second part, which if I now answer this question here, I do my derivative, which is my 2x times sine of x, plus my x squared times my cosine of x, divided by the original function, which is inside there, this x squared times sine of x. Now I can simplify this down a little bit because there's a common factor of x in every term. So if I divide everything through by x, I just get 2 times the sine of x plus the cosine, plus x times the cosine of x, there we go, divided by x times the sine of x. If we do another question now, question 5, here we're trying to work out what the derivative of the natural log of x plus 1 over x minus 1 is. So you can have a think here and quickly see that we're going to need to use the quotient rule. So my function here is x plus 1 over x minus 1. Now the derivative of that function would be my v, so the one on the bottom, so x minus 1 times the derivative of the top. Take away, keep the one on the top the same, multiplied by the derivative of the bottom, all divided by the bottom squared. And if we simplify that down a bit, well, up on the numerator here, if I do this in red, up on the numerator, we've got x minus 1 here, subtract x plus 1. So what we've actually got is x minus 1 take x take 1. So we just end up with negative 2 there. So I can rewrite this whole expression as -2 over x take 1 squared. Now the answer to this question, remember, it's the derivative, so this guy here, which we just calculated, divided by my original function, x plus 1 over x minus 1. So this is the same as if I multiply and then I flip this fraction over. So I actually end up with -2 lots of x minus 1 over x minus 1 squared times x plus 1. And so I can cancel out one of the x minus 1s from the numerator and the denominator, and I get -2 over x take 1 x plus 1 as my final answer there. If we do another example here, so differentiate the natural log of 2x plus 7 all to the power of 4. So here we're going to use the chain rule. So my original function f of x inside of that bracket is just my 2x plus 7 to the power of 4. If I differentiate that, I get my 4 times 2x plus 7 cubed, as I normally would, but I have to multiply by the derivative of what's inside. So I actually get 8 lots of 2x plus 7 to the power of 3. Now, the answer to this question, I take my derivative, 8 lots of 2x plus 7 cubed, and I divide it by my original function, 2x plus 7 to the power of 4. So simplify that down, you get 8 over 2x plus 7. We'll do another one. So question 7 now. So find the derivative of the natural log of x all to the power of 4. Well, if I was to do that, I'd differentiate this thing as if it was just a thingy, kind of like what we did before. So we get 4 times the natural log of x all cubed, multiply by the derivative. So it's a chain rule again. So multiply by the derivative of what's inside. The derivative of the natural log of x is just 1 on x. So as an answer here, we get 4 times the natural log of x cubed. And you can kind of write it like that, similar to how we do with sine squared and cosine squared. All divided by x would be the answer to that question. So we've just got a chain rule there. So we've just differentiated this as if this natural log of x was just a thing, a u, right? So you get 4 times the natural log of x cubed, and then multiply by the derivative of what's inside. So very similar to the last question.